We are going to start off reviewing some basic things that we use for science. And a couple of these aren't even in our book. The first couple here, the first couple topics here, we're using the book Tro. The first couple topics aren't even in the book, but they are useful to know, just so we know what to do with our calculators. The formatting here isn't too great, but when we do 22 divided by 45 times 12, if we type it in the way I just spoke it, 22 divided by 45 times 12, we would get the wrong answer. So what happens is that there's a implied parenthesis for everything above and below that division sign. So to do it correctly on the calculator, you would have to do 22 divided by open parenthesis 45 times 12 close parenthesis. Or the easy way is we multiply everything in the numerator and divide everything in the denominator. 22 divided by 45 divided by 12. And also a reminder, on our tests we cannot use any smart devices, phones, or anything else as our calculator. So we need to have a simple scientific calculator, not a graphing calculator, and we should bring into class and lab so by the time we take our test we are familiar with our calculators, since calculators have different styles and functionalities. We use scientific notation so we can handle large and small numbers. Scientific notation is going to have a number that's between 1 and 10 times 10 to a power, and the times 10 to a power gives us the magnitude, whether it's very large or very small or somewhere in between. And the times 10 to a power, that power will also represent how many places we had to move the decimal place to convert between scientific notation and the standard notation. If that exponent is positive, standard notation gives us a very large number, and if the exponent is negative, standard notation would be a number less than 1. So you have to know how to use your calculator. That's why you should bring your calculator that you're going to use on the test into lab and to the study sessions. So to type a number into a calculator, type a scientific number into a calculator, we do not want to type 4.562 times 10 power negative 6. That will give us the wrong answer half the times because of how the calculator is designed to handle these mathematical operations. If we were to type it that way and we want the calculator to give us the right answer, we would have to put a parenthesis around the whole number all the time. The best way, of course, is to know how to use scientific notation on your calculator. So some use a EE button, some EXP button, some a times 10x button. So there's a couple different ways out there. But you're going to type the first number and then the scientific notation button, whether it's EE, EXP, times 10 to the x, and then the exponent. And for most calculators, the negative sign is different from the subtraction sign. So also keep track of that, and some don't use the negative sign, they use the plus minus sign. Logarithms is another way that we handle large or small numbers, especially properties that can change through many orders of magnitude, such as hydrogen ion concentration for acids. So a base 10 log, log log, base 10 log, if we take the log of a number that we can represent as 10 to a power, it gives us that power back. That is the logarithm. It gives us the power of 10 to a power. And the anti-log will raise that number up to the power on 10. So again, we have to know how to use our calculators for logarithms and anti-logarithms. There will be some problems that we will need to know how to use a quadratic equation to solve. Quadratic equation is when we have an equation with a power 2 in it, a power 2 equation. We arrange the equation in the form of, for the variable x, ax squared plus bx plus c equals 0. So we get everything on one side. And we put the second power first power, and then 0 power. And the number of solutions depends on the power, so power 2 means that there are 2 solutions. And the equation here got slid. We lost something on this. So the equation would be minus b plus or minus. That's the 2 solutions. One solution will have a positive, the other solution will have a negative. So negative b plus or minus the square root of the whole term, b squared minus 4ac. So it's the square root of that whole term. The top of the square root got lifted a little bit, and this whole thing divided by 2a. There are some times when only one answer is valid on this. And if we have 2 answers coming out, you should be able to look at the 2 answers and determine which is valid and which is not valid. It will depend on the problem. An example is if you're looking for mass and you get a positive mass and a negative mass. Well, negative mass is not considered to be valid, so no, positive mass would be the valid answer. We're going to have to be able to do graphs. Most of our graphs we'll be doing on computers, but we should also know how to graph on paper. The computer graphing is a little bit easier since it will do it correctly and avoid a number of common mistakes. But the components on the graph, things that we have to remember to add even with the computer graphing, we need to put a title on the graph, so identify what the graph is. If we have more than one graph and there's no titles, they can be very confusing. The axis should be numbered in a linear fashion. The computers do this automatically. If we do it by hand, we have to just make sure that we are being linear with our axis. We have to identify our axis. So we have to do this whether we're computer or paper. We have to identify the axis. Identify the property. Might be distance, and then the unit. Might be meters or centimeters. So we have to identify both the properties and the units that are being used. When we graph, we set up the graph, we set up the axis, then we're going to have a series of data points. We put the data points on the graph so that it matches the 2 data points. The computer does this automatically for us, and but when we're doing it on hand, we have to make sure that we're doing it accurately, showing where the point truly belongs on that graph. From there, we generally do not want to connect dots. Unfortunately, sometimes the computer wants to do that. We generally do not want to do that. Do not pick that as an option, generally. What we do with it depends on what we're expecting should be done with it. If the property is supposed to be linear, we look for a linear line. If we're fitting it by hand, we want to make sure that the line is a good representation of the data points. That means it bisects the data points roughly the same amount of data points above and below the line, and no bias on either ends of the line. Computer will do it automatically for us. It does a nice linear least squares fit, a mathematical operation that gives us a good averaging of our data points. For curved lines, if we want a line through there and it's not linear, then we do a smooth curved line between the points. On the computer, we can sometimes get a good fit using higher powers, like a power 3, power 4, or such. But make sure it's a good fit before you just accept it. Now, matter. We're going to look at matter. Chemistry is a study of matter and how it interacts with itself. Definitions of matter, anything. Second definition here. Substance composing bodies perceptible to the senses. This is the original definition of matter. You know, it's like if we can see it, feel it, it's matter. A more modern physics-based definition is anything having mass when at rest. We can represent matter in a couple ways. We're going to be, of course, working with macroscopic matter. That's what we see. But we're also going to be describing in terms of microscopic properties, what the atoms, molecules are doing. Plus, we're going to represent it symbolically with chemical formulas, describing what that matter actually is chemically.